Hello and welcome to Section 8, Part 8. In this part, we're going to cover the setup of our formations, and the use of that formation data will be the primary input to our navigation setup. So the formation data is really quick to set up. It's just a data asset. So I'm going to take the time now to cover, there's kind of three parts to setting up the navigation. The first part being that formation data. The second part is the navigation for the groups, so setting up the group positions, and then the third part is the actual entities, so the units in the groups, where their positions are and where they should move to. So I'm going to take the time to explain all that now, and then over the next few videos we'll do those three parts, with the group and the entity parts being probably a lot longer than this first part. Anyway, so this is what's the formation data used for? It is used to specify where you want those, the formation data will be used for both group and entities. So if you look at these black circles and you picture them either as an entire group of multiple entities or an individual entity in a group. So this is, say, one group of three, or it's three groups. It's going to work exactly the same. And then in the formation data, we'll have something called an offset, and that's how you decide the makeup of the formation. So you can see here the offset is -1 on the X and -1 on the Y. So that's how you calculate this position here. So the first position will be at 0, and that'll be -1, 1, and then another setting we have on it is alternating. So the third position will be alternated on the other side, which will make it -1, +1. And that's how we calculate the position. So if we wanted them to be in a line just like this, then we wouldn't have this X offset, we'd just have a -1 on the Y, and that would give us that alternating position each time to build a line, no matter how many units there are. I'm just showing 3 here because I don't have stuff all over the place. So that's how the formation data is going to work, and the reason why we're putting it into a data asset is it's perfect for using it to set the formation. So you can pass around the asset ID, which is a tiny little text file. Basically, you can throw that around and say, hey, your formation is this, and you're actually giving them all the data they need to make that formation. So that formation data can also have any display names, display assets like images that you want to show on your UI to say what formation they're in, or like if you have a button that comes up with a menu and you want to choose different formations, then all that data's in the assets and you can just read it all out. If you've got any formations in your game that aren't used every time, then that stuff won't be loaded for that game session. It's just the best way to do it. So part 2 is groups. So the way the navigation calculations are going to work is we're going to run 2 passes. So the first pass will be, let's figure out a rough position of where the groups will be. So just to explain this diagram, this down the bottom here is where my groups are now. So I've got one group of 4, one group of 3, one group of 2, and the black circles would be the units in those groups. So when I first move my mouse, say, up to here, the first calculation I'm going to do is just, okay, we've got 3 groups, we need 3 group positions. What's the total width of the group? So we can calculate this from each group. We know this one's, for the ease of explaining this, let's just say this one needs a spacing of 2, this one needs spacing of 3, and this one needs spacing of 4. So that's what, 9. So we know that we need an overall distance of 9, but what we don't really care about right now is the 3 group in the middle, or is it on the left? Is the 4 group on the right or on the left? It doesn't really matter. So we quickly calculate an overall width, and we take the average, and we calculate these 3 positions for each group. And all they have to do is be the right overall width that we need, and then what we can do is we can calculate which group is the closest to each position. So the way we do that is with, what would we call it? We do it with a kind of bulky calculation, but it gets us the best result. So what we'd do is we'd say, okay, just replace this word entity with group for now, but we'd say, let's go left to right. So group 1, 2, and 3. So group 1, 2, and 3, what's their distance to position 1? So this would be, 10, 15, and 20, say. So it'd be 10, 15, 20. position 2, what's all the distances, and they've all, they say these two are 15, this one's 10, that basically what we'll end up is what is the best combination of positions where these groups go the shortest distance to each position. Now, most likely it's going to end up exactly what it is if it was this close, and this group's going to go there, this group's going to go there, and this group's going to go there. Now, something to factor in and keep in mind here is if we added one more group here to this table, well, let's just say we only had 2 groups, so I can just show it in this diagram. If we only had 2 groups, we only have to do these 4 checks. Now we add one more group with one more position, now we're doing 9. And when we added another one, it's going up exponentially, right? So it's going to get, when you get quite a lot of units, it's going to be a huge calculation. And that's why we're going to put it on another thread, wait for it to come back. Otherwise, it's going to hitch our game. And we'll be doing that in the calculations. So that's the first part of the group calculation. The second part is now, okay, this group here is assigned to this position, this is assigned to this position, and this is assigned to this position. Now we want to come back and actually calculate, okay, we know which group's going where, we want to recalculate the formation so it fits everyone correctly and they're all in line properly. So that's where it'll start from the center, it'll get the position, it'll calculate, okay, there's a group of 3 going here, so this is the spacing that they need, and then it'll do the next position, and it will be off this position here. So this group needs, let's just say this is 40 spacing. This will go, okay, at the edge of this group, wherever this group ends, so this group ends here, we'll have our group spacing between groups, and then we want to go across, what did I say, 40? So we need to go across 20, and then this will be the start of this group position, and we'll calculate. So we fit 4 in here perfectly with the proper group spacing. We fit 3 in here with the proper group spacing, and then 2. And I hope that makes sense. It's hard to, I've done a few diagrams. I can't really do a diagram to explain it properly. I guess I could say, so if this is the start position, then this group would come in here, and then if this one gets calculated, this group will come in something like that. It's not gonna, let's just say we've got a big group spacing, so we want a decent group spacing. So this group will come in here, and then this one will come in with the same sort of group spacing. It's probably almost lined up. The point I'm trying to make is it might not be on those original positions. They might vary a lot. So if I change that up, say, and all of a sudden this group got assigned to here, and this group is now assigned over here, you can see, like with the group spacing, that these would be something like that. So it's going to be a little bit different to what that initial, this group position is not going to be in the center of every group when you do the second calculation. And then, so part 3 now is to determine the entity positions on those. So we've now got the actual group positions here. Now we want to figure out where the actual entities positions are, and we'll do the same thing again. We'll say, okay, now what we're trying to determine is which entity will go where in these positions that we've established. So we've established the rough positions, but we need to know who goes where. And we do the same table for every entity. So I guess I should have done the 3 one here, but so entity 1 will check every position, and then entity 2 will check every position, and we'll end up with what's the shortest path that everyone has to move to get to a position, and we'll choose that one. You'd assume that this would be the shortest path, right? So 1 going to 1, 2 going to 2. So it'd be, like this would be, so this is 10, and then 2's going to 2, this would be 10, this would be 10. So we end up with these scores to every entity to every position, and then each position is summed up. You'll end up with, like the shortest path for each one, and then it will pick the total shortest path. So, it might be 1 to 3, 2 to 2, and then 3 to 1, but it's probably not going to be that, but it'll average it out. The most likely one is that through the middle there, that 10, 10, 10, because it gives you 30, whereas, you calculate some other ones, you end up, so if we just did what I just said there, 1 to 3, 2 to 2, and 3 to 1. It ends up being 37, so it's not going to choose that. It's going to average it down to 30 or something like that. You know, there might be a shorter one in there, possibly, but it's not going to be 100% perfect. But in most cases, they're going to go to that best sort of setup. Like that would be the outcome that we'd want. We'd want 1 to 1, 2 to 2, 3 to 3 in this situation because there's no crossover and they move nicely, and that's what we want. So then once that's established as who's got one position, then we take a closer look at the entities and go, okay, this entity, oh, this one's a tank. It actually needs, out of the total group spacing of this group, you know, like this one's massive and it takes up double the space, then we're going to alter the calculation on the ground when we come to the second pass for the entities. Something very hard to explain. I hope it makes a bit of sense, but in the end we should end up with a good result on how to move. And I just wanted to highlight how this was all calculated so people can see that's not really made for, you know, there's definitely I want to move 500 units by box selecting them and moving them with this. It's more designed for, you know, like, I don't know, so lower numbers, let's put it that way. It should operate fairly good with fairly high numbers. I've had it going with, I think I've tested 150 or something, so because it's on the other thread, it's just a matter of waiting for it to come back, but honestly, it's not even noticeable. So we shall kick on with the coding. So now into our C++, we're going to come straight to the data folder, create a new class. Going to be RTS entities. And just to speed this up, I'm going to come into our any other data asset, copy, oh no, sorry, we've got a base class for it, don't we? What was the base class? This one. That's what we want. That, if you don't recall, that class gives us our data type, so we're overriding the get primary asset ID and we're passing it our data type. Don't need the data asset include there because it's done through that. All right. So let's just copy a header file out of here. I copy this data type 1. Actually, no, don't do it. Let's copy the name and description because we'll there too. That we'll need. Where were we? Close this now. So I might change this to, oh, that's all right. Name and description. That's a formation data asset. So that's that. And then we'll have another one. Copy that. This will be a soft pointer, object pointer, texture, 2D. Sorry, U texture. And that'll just be the, I'll just call it icon. That's just the image you'd use to display it in UI or something like that. You might have some other imagery as well, I don't know, depends how it's all set up. And then we want some settings. So let's just change this to settings. And our first one will be the offset that I mentioned, which is just going to be a vector. And it will be a vector 3 because although we're not using the Z in this, if you ever, like if you've got a space RTS or something like that, then you'll need the Z to do formations in space. We're just on the ground, so we've just got X and Y. So you could make it a 2D if you wanted, but it's much easier. You don't have to stuff around when you're doing calculations. Oops, I might copy this one. So our next setting is whether it's alternating or not. So I'm just going to call it alt. And that's to go left or right, because you'll have some formations where you don't want to alternate. So a column would be an example where they're all in a line. I get confused here, but column is where they're one after the other. So you don't, unless you want the group leader to be in the middle of the column, you could do alternating, but generally they just want the units to be behind the group leader in a line. So you wouldn't mind alternating in that circumstance. The other one we need is what actual formation type this is, and we're gonna, I don't know if we have created a formation data type. enum is what I'm looking at here. No, let's just do that quickly. Let's just copy one of these. And make it formation type. And then this will be no formation. And the ones we're going to set up initially will be wedge, line, and column. That'll do. We can copy that, close that, and this will be just type. And we're going to include, we'll add the forward deck part actually. All right, so that's pretty much all we need for the actual data itself. And now we can make a choice as to where we want to start working on the navigation calculations, because they're going to be using this data. It's actually not a bad idea to have it on this data asset. So we just say, what's your formation? Grab your data asset and call the functions from the data asset, and it just reads whatever offset the current formation is off the data. So that's what we're going to do. You can put these functions anywhere. So you could put it on the AI controller or something like that, or wherever you're managing your navigation. The first one will be create formation. And then we're going to pass in, by reference, will be our navigation data. I think it was entities. We just called it navigation, so it's going to include data types. I'm going to add an include for that. I'm going to take this reference out because it's going to be included in the data types anyway. So this will be, this needs to be by reference because we want to get this back from the formation. This will be where we store all those positions and all that stuff. And we'll just call that navigation. And then we need to pass in who we're calculating this stuff for. So it's going to be a selection. So I'm going to pass it in as, so we've got two functions, if you recall, with functions, two structs. We've got selected and we've got a selections. So we're going to pass the player selection array. All right, so before we create that function, the next function we'll need is to create the formation positions. And that's what we were talking about with the initial group positions. But this is where this will begin. And again, we're just going to pass into the create, we're going to pass our navigation again and our selection again. And then the final step will be to begin assigning groups and entities to positions. So we're going to call that assign formation positions. Again, we're just going to pass the same. So in our create formation positions, we're going to call create formation positions. Sorry, in our create formation, we're going to call create formation positions and pass our navigation and selections. Actually, one thing we are going to do, and this is to fix a little bit of a odd behavior. So we've come back to our drawing here, groups. So like I said, the formations will work, the formation data will work with groups and entities. So if I quickly say, like, I've got a group here, and I want the next group to be in a wedge sort of formation here, and the third group, you know, like a wedge, the actual groups, not the entities. So, you know, the entities might still be like they are there, so they'll be there, there, and there, like that sort of thing. But when you have two groups, you're probably not going to want two groups to be in this sort of a formation. So what we're going to do is when it's only two groups, we're going to override it always to be side by side, like so. Yeah, if you don't want that, just skip this, or you can have a button to turn it off and on or something. But yeah, so normally with two groups, it's going to be weird if, you know, they're in wedge formation and it's offset. We might exclude column, so we might have two groups that we definitely want to have in column. So we'll check if our current formation's column, and we won't override this. But if it is two groups, we want to switch to a line formation. So in order to do that sort of override, because we're on the data asset here, what we're going to do is we're going to pass the formation data to this next one. So we can pass a different data to the calculation, even though we're on a a formation data asset. We can sort of just pass in a little override here. And we'll also continue that override onto the assigned positions as well. I'm just going to add that to here, to here. Now, in order to calculate this formation data, we'll need the variable. And we'll just make it null. Actually, we can make it this. So now we want to check if we want to override it or not. So we want to check if the type is not equal to, what did we say it was? Column. So if they're not one after the other. And if the selections is less than or equal to 2. So if it is less than or equal to and we're not doing a column, then we want to override the formation data with a new formation data asset. And we're going to create a function for that. And I might not put this one separate, but it's going to return an asset pointer, and it's going to be formation asset. And we're just going to pass in that type. And let's call that type. In here, we want to get a reference to the asset manager. And we want to look up all the formation assets. So we're going to use the asset type to do that. So to get all those, we're going to return in an array. Asset IDs. We're going to need to create a type. And then we need the name of the type that we want to use. So do we have don't have a static data, do we? I might just put this on the asset here. It's going to do a define. We'll use that. And we have to just make sure in the editor, that's what we call our data in the asset manager. That gives us our type name. And then from the asset manager, and we want the ID list. We're going to pass our formation type, and what we're going to store it in is the formation assets. So now we have a list of all formation data assets. We can for loop on those. Now we need to cast the asset to the object. Asset object, and it will be current iteration. So now we need to check if this is the asset they're after. So we're basically looking for the type that we're after here, because this is a generic function to get any formation asset really. So let's check if our formation asset type is equal to the type we're looking for. And if it is, let's return that formation. And then if we go through all of this, and we don't find anything we can be false. I think this is going to be static. No, that's fine. So now this is, we were using this in our, in our create formation here. And we're looking for the line. So now the formation data will be overridden with the line formation if our selections is 2 or less. Otherwise, it'll just use the formation we're working on here now. And then once we've created those positions, we can then assign formation positions. So now we're up to creating the initial formation group positions. So I'm going to hold this video here and we'll continue on in the next one. Thanks for watching. See you then.